Alright, this is a video for the project assembly. So for this assembly, we will not give out slides for this because after you learned Lab 5, this assembly and the drafting, you should be able to assemble the project yourself. So just considering the real world situation, how this vice grip performs, you can assemble this together. So I suggest you to take a look at the slides in Lab 5 and also those constraints, and there's a little bit drafting inside, and also there is a video for the Lab 5 on YouTube. Alright, so let's start assemble this vice grip. I have this part open. It's the jaw handle from the last video. So it doesn't matter if you don't have this. Okay, so it's like if you're just open the NX, it's the same step. We want to build a new file. Okay, but this time it's not a modeling file. We want to build an assembly file, and the units is inch. You want to save to some place, and if you notice here, the file extension is actually exactly the same as modeling. Okay, .prt. So you do want to distinguish them in Windows, so you know this file is your assembly. So what I usually do is I would say, keep those assembly letters there, and say this is a vice grip. So I know that file is my assembly file. And once you have built this file, okay, the assembly, it'll show you, it'll ask you to add the components right away. Okay, so we have this jaw handle loaded. That's why I have this one open there, because if you have multiple parts open, they all show here loaded parts. They're loaded in NX already, and for the vice grip, we need more than one part, right? So we can go open the folder and find your parts. You can load them all together, even the duplicated parts, that's fine. So now they are all loaded. They're not in this window. They're not displayed, but they're loaded in the memory. So usually you don't want to insert all of them at once. It's sort of messy. So I would insert the biggest part, the jaw handle first. And there's some different positioning which explained in Lab 5. So I will just insert this one in on the absolute origin and apply. Okay. So that's our first part in this assembly. And in the Navigator, we will use this assembly Navigator the most. Also, sometimes you want to go to this part Navigator. All right. Now, once we have this on the screen, I'll close this first. Since this one is the biggest part, and I would like to anchor this part in this space. Otherwise, this part is like a free floating, and there's let's try just right click and show degrees of freedom. You can see this one has 6 degrees of freedom, so it can move any direction it wants. So it's fresh, and I would like to constrain this. So there's assembly constraint, and then similar to the geometric constraint in the sketch. So assembly constraint will constrain your parts, and there's a fixed constraint. I can put this piece. Okay, once you click, you can see the little symbol there. So that means this one is fixed. And also in the tree, in the Navigator here, you can see we have constraint here. Okay, so this one is anchored, then all the other parts will be connected to this this major part, the jaw handle here. Okay, so we've added one part. How do we add another part? It's down here, add components. Also, in this assembly, the manual, everything is in here. Components, you can add components. There might be some more sophisticated commands here. Okay, so we can add other components, and we can have a preview of those. So I can add the jaw into this, and usually I just add them to absolute origin. Sometimes you can say by constraint. However, I'll just go absolute origin. As you can see, they're overlapping on each other because that's the coordinate system when we build the part. And also you can tell those two parts are exactly the same on the top portion. Okay, so we need to move this out, and moving apart, okay, it's here as well as at the bottom. Moving parts, move the component, and right click, call this back, and move. And by default, it's this dynamic type of moving. So you can either type in numbers to move that point on the part, or you can simply just drag the directions. And since we build this jaw handle based on the jaw, so we need to flip this one to the other side, 180 degrees. And I'm dragging the points on those arcs. Okay. All right. Now, next step, I would like to constrain this to our fixed base. So, constrain, and we're gonna use a fit constraint, which is used for the same diameter of cylindrical faces with the same diameters. And you have to have the same diameter, otherwise it's gonna say it's gonna be red and it's gonna say it's invalid or something. Okay. All right, now you can tell that's why we model this tip on the y-axis, so they match each other. All right, so let's see if this one is sufficiently supported or constrained. Show degree of freedom. Yes, I can rotate. I do want this part to rotate. However, it can move on z direction. That's the fit constraint. It will only align those center lines together, but not on the position wise or on the axial direction. There's no constraint on that. And if I move this part on z direction, they're still aligned looking from the top. However, the z direction is off. So we can add another constraint. There are a couple ways to add constraints. You can click this one. You can right click on the part, and there's constraint here. And let's see. I want this part to be centered on the jaw handle. Okay. Or there's another way is touch align. Since we know these two parts, the jaw portion, are exactly the same, and those two top faces, they should be at the same, or they should be coplanar. Okay, so we can use touch align, and prefer touch, it'll automatically pick or touch or align. So let's try this. Pick the top face and the face of that. Now if we check the degree of freedom, it can only rotate, which is good. And so next we're gonna add more components. So components is not necessarily a part. It can be another assembly. For example, if I have this plier, this vice grip in a bigger assembly, I would assemble this, and in another assembly, I would load this assembly into the bigger one. So this will be a sub-assembly. Okay. Next we can actually load all of the other parts. I'm holding down Control to multi-select. Say OK. So it's a little bit messy, but you can always move them out. And you want to pick orientation, then the dynamic coordinate will show up. Okay, apply somewhere here, and I want to rotate 90 degrees. It'll snap 5 degrees each. Okay, then the release here. All right, now we can try to put those two together first. Then that'll be a fit constraint. And this hole to that hole, and they're in the same diameter. Hopefully you made them in the same diameter. Okay. All right, and we need to flip this whole thing 180 degrees. Then we need another constraint. It's, again, that's a fit. Okay, for those two holes. So we'll gradually having the shape of the vice grip. Okay, and as we know, fit doesn't constrain on the axial direction. So the other way we can do is besides the touch align. Okay, let's see. We can use another constraint, which is center, okay, because you do want this part to be centered on this part. Let's see, F8. There's a gap between, so you can't use touch to make this face and the bottom face of the grip to touch. Otherwise, that'll be non-symmetric. Okay, so we have this center constraint. We can use that for a pair of faces. That's what 2x2 to 2 means. So for example, our grip, you can pick two faces. Then it'll know the center of those two faces is in the symmetry plane of this grip. Then you want those two faces to the center of those two faces to be coplanar or to overlap on the center of those two faces. So this way, if you check the degree of freedom, it cannot move on the axial direction of the cylindrical faces of that hole. Okay, it can move up and down, it's fine, because we need this to open and close. Alright, now again, this one you can check this. See, that's a fit. The axial direction is not constrained. And what we can do here, it's kind of tricky because because this one was a big swept, so there's no top and bottom flat faces. So let's try to use some workaround method. And when we were inserting the parts, you notice it's deep down in here in the setting. That's the reference set. The reference set model is this. The reference set is this assembly reference. However, remember each part has their own coordinate system, their own origin point, but they're not shown here, right? So if I right-click on one part and then change that reference set to entire part, so it's actually gonna replace, or it's actually gonna bring back the coordinate system of that individual part. And as you can see, we have this this datum coordinate system was on the center hole of this release. So as well as we needed to replace the reference set for the handle. Okay, now we're focusing on those two parts, so we can hide everything and show the grip and the release. So now we have two datum coordinate system, and with them we can ask this release to be centered on the grip. How do we do that? We can say touch align. We're gonna pick it's messy. Okay. The XY plane of the release, and make this to touch or to be coplanar to the XY plane of the grip. Now we can take a look at the degree of freedom. It cannot move on the Z direction now. And also when the grip moves, most of the time the release is actually not touching the link in between those two, the handle and the grip. So we don't want this to move all the time without constraints. So we have it's just my thoughts is to fix the relative position of the release to the grip, so it will not move. It don't move along with the grip. And let's see how we do this. With the help of the datum, we can do that. We can add a angle constraint between two objects. So the XY plane, they are coplanar, but the YZ plane, now they're at angle to each other. So I want this, the YZ plane of the grip, to be at certain angle to the YZ plane of the release. And that angle, we can adjust that angle here. So how big the angle you want that to be. I would say 150. As long as it's not touching the inside of the grip, and that's okay. Alright, so basically those two are now they're gonna move together. Okay, and if I try to move this part, so you see I cannot move this anymore. Okay, so they're relatively fixed to each other. And there's another method is without so much hassle to bring up the reference set. We can make them back to the model again. Okay, this another method is bond. So bond, you simply just glue those two pieces together, touch or not touching. They're gonna be considered as one part. That'll be much easier, I guess. Okay, so I want to see all the other parts and how this behave when we move the part. Okay, we're still missing one part here. That's the link, and let's try to figure out the position of this. So it should be like this. This 90 degrees that sits on top of the screw, and this hole goes into this the hole on the grip. So first we're gonna put this using a fit constraint to put this hole aligned with the hole in the grip. And next it's a little bit tricky to put this on the top of the screw. And also even though we made a detailed threads on the screw and the jaw handle, I did some Googling, and as well as I tried to mate the threads faces together, but there's no I didn't get I didn't get good results. So I'll just ignore this, just let them interfere with each other, and use some other method. So first we want to put this screw into the hole here. We can't use fit because the diameter is different. So we can use a touch align again. There's another type of touch align inside. Here it's invert center and axis. So it'll align cylindrical faces with different diameters. So once you hover on the cylindrical faces, the center line will show up. Now you can pick a center line, then pick the other center line. So now they are aligned. And next, I want to adjust the distance between the screw to this jaw handle. So I will pick this face and that face, set it a distance between them. Okay, and you can try any distance. And I found this one it's pretty short. When you want the jaw to move realistically, you need to insert this screw deep inside the handle. And since this is inside, it's hard to modify this. I'll just hide the jaw handle. Then we need to put this on top of the screw head. So we're gonna use two touch align constraints, one for each side of the face, those two faces here. So I want this face to touch the left side of the edge, and the top and the bottom, I think it doesn't matter really, because that's 45 degrees and that's 90 degrees, but we'll see. So you want to click on the right side of that circular edge. Okay, and now we need to change that to wireframe. And I want the face behind this face to touch the right side of that circular edge. Okay, so I guess the modeling on the link was a little bit off. So that's why it'll look like this. And that's the best I can do. Otherwise, you might need to change the geometry of that link. And notice here, it's not really touching on the particular face. So the touching constraint is only for, it'll touch the extended face. So it's actually touching on the edge, but it's touching the infinite plane where this little face is on. Okay, so that's the explanation for the touch constraint, and the position of the screw or the distance here determines how wide this jaw can open. Okay, let's take a look at the degree of freedoms here. Yeah, so the screw can rotate, it doesn't matter. It will not change the relative position from the screw to the jaw handle. So we can just try to move this grip to take a look at the motion of this. And by the way, assembly is not meant for motion analysis or any of those. I think there's another module, motion simulation, for this kind of application. Okay, so my movement is the jaw opens pretty wide. If you change that distance bigger, make the screw comes out more, the movement of the jaw will reduce. You can play with this. That's kind of fun. All right, so that's all for the assembly. And sometimes if you want to take a look at the cross section, for example, how the threads look, so we can add some section here. So there is sections in Assembly Navigator. Right click a new section, and you can change different cutting planes. So we have a plane that's normal to Z direction, and you can say I want that to be on Z equals 0. So this is on symmetry plane of the whole thing, and okay. Okay, now you want to expand this menu here. If you once you click this checkbox, it'll show the outline, the intersection lines of the cutting plane and the parts. So we can see the screw is actually a little bit off, and I really can't find a good way to make them match each other. And here the link, this dimension on the link might be off a little bit, so that's the best we can get. You can just go back and trim this off a little bit. Alright, so how do we turn this off? You can uncheck this, it'll kill the blue lines, and you can double click on the sections, it'll make this go away. And once you want to see the cross section here, you can double click again. Okay, so that's enough for the assembly, and we do require you to make a general drafting of the whole assembly and also one of the parts. So here I'm going to show you how to make a drafting for the whole assembly. And the details on the drafting is in the video for lab 5. So once you hit start and drafting, okay, and we will be in drafting right away. So now we're in drafting, and it asks us what kind of paper you want. So you can use standard size, or if you're from Siemens, you can use a template. They do have a template for Siemens with the logos and the different sizes. Okay. So if you use that, and you have the option to start from a wizard or just a base view. So let's take a look at the default settings here. So that's the template, and it'll ask you to type in those values in the table. And there's somewhere, if you skip this step, there's somewhere you can also change this. All right, so this is the wizard. It'll ask you which part you want to draft, because we have loaded all those parts inside NX. Okay, so I'm gonna pick the assembly. then there's options. Usually you don't have to change them. Okay, and the orientation for your first the main view of your part. Say top. Okay, then that's the top. So once you get the main view, it'll ask you what other views you want. Do you want this view as well? Left or right? Okay. So for this particular assembly, you don't really need those two views. I'll just leave one view on the screen. Okay, so the box around this the lines, that's the boundary of your view, and you can drag this around, or you can double click. That means goes to this default action on the menu. That's the style here. And so what if we want to add other views after the wizard? So there's a projected view. You can project another view from this main view here, or you can add the main view. That's here, base view, or we can call this base view. So we have one base view. If you import or if you project another view from this one, that's not a base view, that's a projected view. Okay, so you can see from here, and we can add another base view, probably isometric or something, and so that's a 3D isometric view. Okay, so from the navigator here, you can see we have one base view, two base view, then that's a projected view from one of the base views. Okay, and dimensions, again, that's the same as your sketch. It's infer dimension most of the time. It'll snap to the points you gave that. So for this script, it's really hard to dimension this whole thing, because this is movable. The screw can move in and out, so you don't have a definite height or length of this part. And let's see, then we can just dimension some of the critical dimensions. First is the radius or the diameter of this hole. But remember, this is a 3D geometry. If you move your cursor here, it's snapping to the edge of, and all the stuff underneath this 3D geometry. So for diameters, you want to pick the arc center, so it knows this is a circle. And if you simply click on the edge, the arc, that'll work too. Okay, so those are pretty, that's our critical dimensions, and let's put somewhere nicer. Okay, so you would say some of the dimensions are actually fractional. I think of those two. So how do we change them to fraction dimensions? Pick them up, right click, and style. So inside here, let's see, in units, you can change this to fraction, and also you can change the position to 64th and apply, and you can see that's fraction dimension, and that one, I think that's a decimal. Okay, alright, so that's how you add dimensions and change them to fraction. And there's a global setting here, preference, annotation. So that's all the, you can change all the dimension to fractional here. However, this only affects the dimension you add after this action. Alright, now what other things I have to talk about? It's so sometimes you want the one of the views to be rendered, not like this wireframe. You can right click and style, and in the style for the view you can change shading. Okay, the default is wireframe, and sometimes for this especially for the 3D view you want fully shaded. Now you can apply. So that's how you change the rendering of the view. And we will require you to add one cross sections, and that's detailed in lab 5 video. So I'm just gonna do it here really quick. Section view, and I'll pick this view to cut, and then I'll click on one of the center point, so it'll cut on the center. And that's our cut, the cross-section view of the this assembly, and that's very not very nice place. And how do we sometimes the cross-section view, they only have the cross-hatch area without those lines. That's not touching the cutting plane. That's behind the cutting plane. So you can edit the style. In this section here, you can see the background is checked. So if you uncheck background, apply. Now that's the area where the model touches your cutting plane, and it will not show what's behind the cutting plane. Okay, looking from this direction. Alright, so that's all for the assembly and the drafting, and this concludes our CAD portion of the lab. Okay, thank you very much.